us! Among Us, are you a crewmate? Or are you an imposter? Imposter. And that's about it. Let's get to start with. Today we're going to talk about mechanics. Mechanics is what makes this game work. And it's what makes that phone work. And it's what makes all of your most favorite and beloved ideas and videos and everything work. Let me explain. Let's start with forces. Now, forces are basically just two things. Pushes and pulls. That's basically it. That's what a force is. It's where you're pushing something or you're just pulling something towards you. And with that, all you're doing is just doing all those. And with the right combination of those, you can literally create any force. Now, there are different ways to make these pushes and pulls. And there are different materials that can push and pull on other different materials. Sometimes it's all the other different materials. Sometimes it's just specific materials too. Like iron has a push-pull system of magnets that can only affect other iron or other magnetic metals, which are nickel and cobalt, and variations of them, with elements of them. And that's pretty much it. And it's just an example of pushing and pulls. And with these pushes and pulls, you can literally do anything, like push over Mount Everest, or create electricity, or create magnetism so that you can literally kidnap every iron being in the world. Oh yeah, and also ground a lot of airplanes too. Oh my gosh, my neck. And then we have density. Density is not how heavy something is. In fact, it's like related to mass. Density is how much mass is inside of it, how much stuff is inside of it. And that's pretty much how density works. The denser you are, the water, that means you can float on water. That's why steel ships can float on water while a bunch of wood cannot. Well, they can, but if there's too much wood, they cannot. Let me explain. Steel ships are built in a way so that there's a lot of air inside. And air is denser than water. And the steel, well, with air inside, basically goes ahead, makes it denser than water. This is what makes rowboats float too. However, some certain objects, like actual steel itself, do not have air inside of it. It's more dense together because it's more packed together. And with that's the only reason why it's more dense than water. Next, we're going to have to talk about pressure. Pressure. Yes, I'm talking about that kind of pressure, not the pressure that makes stuff weird and very, very red. Well, here we go. Pressure does make things red. Sometimes it's just because of pressure that things boil faster, or more pressure means it boils less. Like, you've ever heard of that time, like, go up a mountain, boil water, it boils faster. Well, yeah, that's true because of pressure. In fact, pressure actually goes ahead from atmospheric pressures or water pressure. Now, let's start with atmospheric pressure because that's what we're experiencing every day. In fact, it's happening right now. It's just minuscule that I can stand up and fight against it. Well, do you like that analogy? No? No? Yes! Anyways, let's go ahead back to atmospheric pressure. Now, atmospheric pressure on our Earth is usually less than 1 atmospheric pressure. That's basically call it 1 amp, and not amplitude amp, but just amp. And with that, that's pretty much how we can do it. If it's less than that, you're basically going to have a very, very flammable planet, and everything will burn because there's too much oxygen. And you need more nitrogen than oxygen. Atmospheric pressure is what's pushing on us. Now, if you're on Jupiter, let's say, gravity is stronger, and the atmosphere is pushing more on you, so you're just going to have to push harder on it too. And our bodies are not built for that, meaning our bones will literally snap before we can even adjust to these temperatures. And probably the only people who can, actually have a little chance of standing up against this new atmospheric pressure are weightlifters, or people who have ran a lot, insanely a lot, so that they have really, 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 really sick bones. Either that, or they just got a mutation, which is really, really, really rare. And then we have to talk about water pressure. Water pressure itself is a whole different level. In fact, sometimes it's easier to make water pressure higher than atmospheric air pressure. Now, the Mariana Trench, possibly the deepest place that we know, well, currently the deepest place that we know, is basically the only place that we know that has the most water pressure on it. Because, weight heavy. If you put more weight on yourself, you're going to have a lot of strain, and you're going to have to cool down. Water has weight. We know that. And it's because of that water that we know lots of things. Now, if you put on more water on top of you, you're basically just gonna, well, have a lot of pressure on you. And that pressure could destroy things. In fact, if you go too deep, everything, even your diving suit, could crack because there's too much weight on you. That's basically what pressure is, having too much weight on you. Air has weight. We've proven that. And water has weight too. We've also proven that. And now, next we're going to talk about turning forces. Now, this is what makes stuff work. It's what makes wheels move. It's what makes centrifugal motions work. It's what makes lassos work. It's what makes washing machines work. What the heck is what makes CDs work too? Turning forces, basically, I like to call them centrifugal forces, centrifugal energy. In fact, it's just about like spinning something so fast that stuff will just flow to the outside edge. In fact, the outside edge must spin faster than the inside of the circle, just so that it can keep up. That's how things start working, and this is why portals should probably not work, and why you should run through portals, because like the Earth is moving at the same speed, and the different places, if you're closer, then you're slower, the Earth moves slower, and if you're far away, the Earth moves faster, just so that the Earth can keep up with the time constraints. And with that's why stuff moves to the outside of a circle if the circle spins insanely fast. In fact, centrifugal motion is also the way you can unboil an egg. Also, it will not look like an egg, it'll just be those powdered egg. I mean, yeah, I guess that's still egg. And then we'll have to talk about work, energy, and power. When I hear this, I actually think of ATP, the energy of light, and a very, very inefficient energy source too, because you need millions of ATP just to be alive for a second. That's very inefficient. But if you have loads of ATP together and you store them in a lot of glucose, you only need like 1 million glucose to stay alive for, well, way much longer than a second. And with work, energy, you can't do work without energy. You can't do work without power too. You need power. Power is powered, see that pun, with energy. And work is powered with energy too. You can work just by moving up and down. That's considered work too. And by work, I don't mean like violinist work or eyeglass work. I mean just moving itself, just standing up, sitting down, moving, running. That is all considered work, and all that needs energy. And you also need power. How powerful it is depends on how it is. If you go on a light walk, that's not that much power. And if you go on a very, very big run, that's more power. And if you're gonna go about as fast as speed of light, that is a bunch of power here. And I can run really, really fast. I once even caught up with a bicycle for a few seconds, and then I stumbled. What a shame. Now, to make this work easier, we have to exert the forces. We usually just put a little bit of force inside a machine so that it'll create an equivalent but a proportional but larger amount of force. And these we call machines. Yay! Also nowadays, it has to do more with brain power now. Usually, in today's world, we usually create machines to improve our brain power. Back then, we used machines to improve our physical power. Let me explain. Now, there are lots of simple machines. Pulleys, ramps, or levers as it's sometimes called. Ramps or inclined planes, levers as I already mentioned, and loads of other simple machines too. And if you combine these simple machines together, pulley with a ramp or inclined plane as it's also called, then you basically get another complex machine. You get another machine, except this is more complex. Because it's a simple plus simple plus simple plus simple. It depends how many simple machines put in. It doesn't matter how many simple machines put in, as long as 2 or more, you'll get a complex machine. It can also be the same type of simple machine too. Although I'm not sure that's really considered a complex machine as complex as a simple machine and another simple machine. And that's pretty much it about machines. Now, keep in mind that nowadays we usually create machines to improve our brain power, not our physical power. We sometimes do that just because of our limitations with this physical power. However, we usually want to improve our mental power because we want to be Brainiac! Or we also want to be MODOK! I am the old sort of MODOK. Also, I'm not sure he's that smart. I mean, Spider-Man outsmarted him so many times. So did Captain America. And last two things we're gonna have to talk about: velocity and acceleration. Well, that's okay. I'll admit it. Last three things we're gonna have to talk about: velocity, acceleration, and momentum. Velocity is how fast you're going. Acceleration is the speed, how faster you're going, how much speed is changing, the change in your speed. And momentum is the power that lets you go up, that lets you move. Like, if you build up momentum by just swinging around, you can fling it out, and then the energy that you stored here, that was stored as potential energy, turns to kinetic energy when you fly it out. Because as you spin faster and faster, you're giving it more energy. And then when you release it, you turn all that energy that you built up, the momentum as we're calling it, into kinetic energy. By building up this type of energy, you're building up momentum. More momentum, there's more potential energy. And with more potential energy, there's more kinetic energy. Wow, that is very science nerdy for me. And acceleration. Acceleration is just the speed, the changing speed, how much faster or slower you're going, how much you're accelerating or how much you're decelerating. And velocity is just the constant speed you're having at right now. And that's all. That's all for mechanics. Now, this was a really big chapter, and I really hope you guys enjoyed this episode, and I hope to see you guys soon. So until next time, Schnarr out. Peace.